Once again, our disclaimer one more time. This call is being recorded and we place our recordings on our YouTube channel. If you're not comfortable with it, you may want to drop off now. And Kumar, floor is yours. Please take it away.
Yeah, sorry, I forgot to change the date, but I will correct it. Good morning, good afternoon, everyone. I would like to briefly talk about Azure HPC solution and how customers can take advantage of running EDA workloads in Azure. Based on the poll, it looks like some of you have heard about it. Some of you are new to this, so I'll do my best to kind of fast track it because HPC is a huge technology, pretty much used to run big compute workloads. So I'll just talk about for 20 minutes, and then in the last 10 minutes, I will just give a brief demo. Okay. My name is Kumar Raju. I'm a CSA in the Microsoft manufacturing unit. Okay, so how big compute and Azure evolved and how we have made it easier for customers to consume, right? So as you could see, you might have seen a similar slide anytime we talk about migrating customer workloads to Azure, right? The customers are all in on-premise. They have been running these workloads. It requires them to procure the hardware, software, and manage the data centers and everything. So scheduling software is key in HPC workloads, but it has been available for quite some time, right? But you always have these CapEx and OpEx costs to deal with, right? Then we moved on to this hybrid scenario where you can still run your workloads in on-premise data center, but you can burst the workloads by taking advantage of one of the public clouds. In that case, you kind of set up these secure connectivity to your public cloud vendor, like in case of Azure, it's a site-to-site VPN or express route, and leverage their solutions to run these big compute workloads, right? But then as customers, wanted more. As we have seen the market evolving, there's an increased demand for pure, IaaS-based clusters because you get to take care of the cloud vendors, elasticity, flexibility, pay as you go, and then you'll be able to replicate it to multiple Azure regions, and then you can always scale up and scale down. So we kind of evolved from on-premise to hybrid to IaaS. But then the next thing is, customers also wanted to do something with the cloud native, right? Like, they do not want to worry about managing these IaaS-based virtual machines too, right? So then Azure has a solution for those to cater to those customers. So by using the cloud native, the customers or ISVs can actually develop some sort of a SaaS solution for their end users, and then they don't have to worry about infrastructure, scaling and all those things. So those things are provided out of the box by Azure. So to cater to all those needs, so as you started off from on-premise to hybrid to IaaS and the cloud native, right? So Azure has two solutions to cater to the customers. One is a PaaS offering, which we call Azure Batch, and the other is IaaS-based solution called Azure Cycle Cloud, right? So today's discussion is going to be more on the Cycle Cloud, but I also wanted to spend a couple of minutes to talk about Azure Batch as well. So Azure Batch is some sort of a batch as a service solution for you, or HPC as a service, right? So Azure Batch is actually a cloud-based scheduler, where if you are doing a cloud-native deployment development, you consider deploying your big compute workloads in Azure Batch. Behind the scenes, you might have heard about Azure's virtual machine scale sets, the virtual machines, and all those things. But all the infrastructure management is taken care for you, kind of seamless for the customers who are actually using it. You focus on the developing your application and making it available to the end users. Everything is taken care by Azure's high availability redundancy, availability zones, whatnot. right? And then, as I said, we also have the hybrid or bursting model, where you still want to run in on-premise, but you wanted to use Azure for certain bursting workloads. So you could actually use our IaaS offering called Azure Cycle Cloud. That can be actually run in on-premise too, because it's essentially an installer that can be deployed on a virtual machine, right? But on the extreme right, what you see is Azure Cycle Cloud, where it's completely deployed in Azure in a virtual machine, and from there you can orchestrate the HPC workloads in terms of the compute, storage, all sorts of the schedulers that are very known in the market, which I'm going to show you in the demo. So that's how we have a solution for it based on the customer's needs. Whether you want to go with a pure PaaS-based solution, which is batch as a service or HP as a service, or you have been using these big compute workloads for a while. You wanted to have a sort of lift and shift solution. You are not planning to really reinvent the wheel. You wanted to use as is. So in that case, Azure has a solution that's called Azure Cycle Cloud. So some of the features of Azure Batch is obviously it's too good in terms of we call EP, which is embarrassingly parallel workloads, right? If you are planning to run these independent workloads, then Azure Batch is very highly scalable in nature. It doesn't mean that you cannot run MPI, which is dependency-based workloads. You can still do that. We take care of you don't have to really redo about any programming logic. If a job fails, we take care of detecting and retrying it. But most importantly, it's ideal for developer base. You can run your programming in any of these development programming languages like it's .NET, Python, Node.js, whatnot. All those things are available. You could actually configure right from the Azure portal, right? You can either use Windows or Linux operating system of your choice. And as always, the customers can take advantage of Azure hybrid benefit or Spot instances. Because remember, these are batch workloads that can be run at off hours if necessary. And sometimes customers are okay to run on Spot VMs too. All right. So Azure Batch really provides these some sort of rich features in terms of the compute, in terms of the developer access, and job scheduling is done whether it's massively parallel execution jobs. So these are some of the workloads that you can do. For example, if you are running some sort of the fluid dynamics or some sort of image processing, 3D processing, we do have these appropriate compute available like the NVIDIA series or GPU VM SKUs. They're all available for customers. They could just use those compute to run these big computer graphical workloads. That's where an Azure Batch really scales very well. Now let's talk about the Azure Cycle Cloud. So Azure Cycle Cloud is an IaaS-based solution. It is some sort of an orchestrator. You as a customer come and say, I wanted to run some sort of a workload, which I'll talk about what are those workloads are. For example, the customers typically come from this background of you might have heard about these schedulers like Slurm or IBM's LSF or PBS Works Grid Engine. So these are very widely known in the HPC market or the EDA market. For example, the customers are in the semiconductor industry. They have been using this. This market exists for close to 40 years. The chip companies, the semiconductor companies, typically use these to simulate those EDA workloads. So that's what Cycle Cloud provides you out of the box. They let you pre-provision these schedulers when you configure a cluster, right? So let me go back to my previous one. Yeah, so essentially it's provisioned in a virtual machine. It's some sort of a web server / app server. You directly consume from Azure Marketplace. You run it, and then you start provisioning these workloads by specifying the compute and storage, and then the networking, which I'll show you in a moment. So it all makes sense to you. But essentially, it provides a secure experience. You can directly integrate with Azure Active Directory, or if you want, you can just create standard logins. You can do SSH access and whatnot. All those things are available out of the box, and we take care of this auto scaling, again, spot instances, and all those things are available to you. But this is typically used if customers are already familiar with these known schedulers like Slurm or PBS or IBM's LSF schedulers. Some of these are open source, some of these are some sort of a commercial offering, but then that's where you will use your existing licenses to run these batch workloads. Yeah, so now I'm kind of pivot this conversation to electronic design automation. So what exactly it is, right? This is widely known. If you talk to the customers, like for example in Siemens or Intel or AMD, because that's where those guys are focused on, where they are involved in these chip design, right? So they have to do this some sort of this is similar to the quality assurance testing, right? They need to follow a certain methodology in terms of packaging it, testing it, and the whole life cycle. It's a big process involved, and it has been in the market for a long time. So it is actually not a tool, but some sort of a market segment consisting of software vendors, hardware vendors, and services, right? And then the goal for these customers is to kind of assist in defining the process. Again, if you see the DevOps process or in a quality assurance process, they take care of designing it in a fabrication devices or chips and all those things, right? We talk about microprocessors, so you talk about memory chips or graphic cards. So all those things that need to be make sure they are fully quality controls and fully tested, right? And these tools, EDA tools, kind of make sure they go through these processes before they release it to the market. And this has been a huge market in the semiconductor industry. And as we see a lot of supply chain issues now. And if you see these are mainly used by these providers, like they have these fabrication factories or semiconductor foundries, like you see these chip companies like AMD or Applied Materials or maybe Intel. Some of those customers have these foundries who run these chip design and all those things, right? So with that, what I would like to show you is I also wanted to kind of show you what exactly we mean by EDA. Can you still guys see my screen? I just want to take a moment to play
Yes.
this video so you get an idea.
Yeah. Yeah.
Electronic Design Automation, or EDA, is a collection of hardware, software, and services aimed at one goal: the design and manufacture of advanced semiconductors that are impossible to make without it. The EDA industry began over 40 years ago. Since then, EDA has delivered about a 10 million-fold increase in design productivity. And with the current prevalent use of semiconductors for things like AI, fully autonomous cars, IoT, and more, EDA must deliver more productivity than ever before. Today's advanced semiconductors contain multiple chips and technologies, with billions of transistors all packed in an ultra-small form factor. And all of it must work flawlessly, meeting demanding power and performance goals on tight schedules. There is no way to do this without the sophisticated hardware, software, and support EDA provides to design and manufacturing teams, so they can predict and optimize performance and better ensure a manufacturable result. There is also a pressing need for pre-verified building blocks to reduce design time. EDA delivers all this and more. Architectural analysis, simulation, verification, physical design, manufacturing, semiconductor IP, and application software development are all enabled by EDA. Electronic design automation is at the heart of today and tomorrow's industry.
Yeah, so again, uh, if you guys are unfamiliar with this technology, I would highly encourage you to check out this EDA, but that's what I wanted to show you. But as you could see here, in the last decade itself, anytime these chip companies design these chips, right? The transistors have really, the latency has really gone down from, let's say, from 40 nanometers to 7 nm, right? And it continues to go down, right? And then, but to run these workloads, you need to have very highly compute workloads to run, right? The beauty of the cloud is you can choose and pick the compute that you need, and then you run it. If you see in the last decade, the demand for compute and storage continues to grow by 30 to 40%. And it's going to go in the near future too, as customers set up these cloud computing platforms. So this is a typical production EDA cluster look like. To run these schedulers, you need to have some sort of license, similar to like, let's say, if you're working with Microsoft, you need to have Windows licenses or any other software for that matter, right? So either customers run these license servers in on-prem, or they kind of host these license servers in Azure, right? And they'll install the Cycle Cloud, either in on-prem or Azure, however they want to. They have this some sort of a secure connectivity. Sorry, what happened? Yeah, secure connectivity, whether it's site-to-site VPN or express route. And then what they do is they kind of orchestrate the compute and storage in terms of for HPC. Essentially, they use Azure NetApp files that gives you much IOPS and everything. But you can use any of those NFS services if necessary. But on the right-hand side, you see the compute in the form of virtual scale sets that can be scaled up and down. Right. Essentially, HPC, the way we would like to call it is, it's not HPC in the cloud, but it's a purpose-built cloud for you, for the customers, right? So, and at the end of the day, HPC is a mix of a beefy compute, right, and an InfiniBand networking and high performance storage, right? But most importantly, you also need to have some sort of a tool to orchestrate all these things together, right? Whether it's plus compute plus storage plus networking. That's what this Azure Cycle Cloud does. But HPC can be really used not only for EDA, it can be used for machine learning or deep learning or supercomputing and everything. But today I was only talking about running these EDA workloads because that's where a lot of the semiconductor industries do that, right? And just to give an example, this is something that we kind of present it to our customers in conferences too. When we say purpose built, these are some of the high performance VM SKUs that are available in Azure that really lets you run these big compute workloads, whether it's ranging from 24 cores all the way to 200 cores, right? I mean, you can just read in our documentation. All these are available in InfiniBand networking to gives you low latency. You name it, we have compute for you to run these workloads. Similarly, for storage, you can use Azure NetApp files, which is highly recommended, but you can run any of these NFS. It all depends on what your workload is, right? So with that, I would like to really kind of and just directly dive into the hands-on demo. So yeah, if you haven't heard about InfiniBand, essentially, if you have a series of compute, it lets you run these workloads in a low latency network, right? If it is just running on one compute, then you don't need InfiniBand. But if the job is split across multiple virtual machines, and they need to communicate on a low latency, and that's where InfiniBand plays a bigger role. And it's very quite common to use in running big compute workloads, right? But you don't need to really do anything. You just use one of those available supported VMs, and you'll be able to get out of the box. So with that, I will directly jump onto the VM. So how do you use really the Azure Cycle Cloud? So typically what you do is you can actually go to the Azure portal. And then from the Azure Marketplace, I look for the Cycle Cloud. Then you can just provision Azure Cycle Cloud VM, right? Now, as always, we have different versions. So all you have to do is you just come and create it in a virtual network in a resource group. In a virtual network and resource group, and wherever the region you want to be with secure access and everything. And within a few minutes, you'll have your VM provision, right? So in my case, I already pre-provisioned the VM beforehand. So this is my virtual machine, okay? It says it's running on CentOS with my publishers and all those things. The next thing you do is you access this virtual machine. Ideally, for the demonstration's sake, I'm running on a public IP. But typically, if you have if you use a Bastion and everything, you could just run on a private IP too. So if you see, I'm running on this a private IP, sorry, public IP. So you just hit that. This is the um, home page of Azure Cycle Cloud. So typically what you do is, as I mentioned, it's an IaaS based cluster. The difference between Azure Batch and Azure Cycle Cloud is Azure Cycle Cloud runs in the form of clusters, whereas Azure Batch runs in the form of jobs, right? So you provision a series of clusters based on your need. So for example, if you see here, um, so these are all the uh, schedulers that we provide out of the box. But if you are using a scheduler that's not available here, you can always, there's a process to pre-package those and make it available to you. But these are widely used schedulers to run the EDA workloads in the EDA market. So Slurm, and then LSF is from IBM, Altair is very, very famous and everything. And as I mentioned, you can also use these file systems, NFS or whatever, or you can use Azure NetApp files if necessary. So for the sake of this demonstration, let's configure a Slurm cluster, which is widely used, right? Um, So you initially this is a one-time process that you kind of configure this. So you kind of configure this in whatever Azure region. So based on your workloads, you have to pick up the right VM SKU, right? So that's where the flexibility comes into the picture. What's your work? We have a guidance that we provide, but in the interest of time, I'm unable to show you that, but it's very well documented. So you can just define this, and then you can say that I want to scale automatically based on the demand, how many cores that I might need at any given time. You specify your subnet and everything, and within a few minutes you should be good to go. It's as simple as that, right? Once the cluster is provisioned, right? So I will not provision this. So as I mentioned, Azure Batch lets you run in Windows or Linux, but in case of Cycle Cloud, most of these schedulers are very famous in running in the Linux. So if you see, these are the ones that we support, like Alma Linux or CentOS or Ubuntu, because they are primarily Linux-based schedulers, right? So you can define these schedulers, and that's all you have to do. And if there is a need for you to really do some sort of a cloud in it, you wanted to install some software before running up those head nodes, you can do that. In my case, I have provisioned a cluster. So once the cluster is provisioned, you're gonna start it, and that's what it's gonna look like. So what happens is, this is a scheduler, which is a head node. This scheduler essentially kicks off these jobs and workloads. So the customers typically log into this head node, and that's where they'll install their tools as needed and kick off those workloads. So as you could see, I have been running bunch of those workloads, and then I'm able to run this. So sbatch is a Slurm based command. So typically you will run this um, syntax that I'm saying that I wanted to just run a task on a node, and output it into some log file. And again, just for the demonstration sake, I'm just printing a host name, but this is not the real workload. But this is a syntax that most of the EDA customers are familiar with it. So you don't have to worry about it. We are provisioning or giving you the infrastructure and compute, but this coding is done by the customers or software vendors because they know what kind of jobs they will be running it, right? So you will head on to this the scheduler node. You can SSH into it, then you kick off these jobs. But if you see the Cycle Cloud, each has these the scheduler nodes. It gives you a wide range of reporting. If you see this, I'm actually running a bunch of those jobs. As I mentioned, it is auto scaling all those computes on demand. And when the job is done, it kind of terminates and deallocates it. So you're only paying when the jobs are actually run. It's really, really spinning up this compute at scale. But as soon as the job is done, it's kind of deallocates it, right? And then as you could see, You could also do this monitoring. So for example, since yesterday, I'm running some workloads. So far it has run this many, core hours and how much it cost me. As part of the monitoring, you could actually set some alerts. What's my budget is it per month or per day? You could actually get notified. So the Cycle Cloud is some sort of an orchestrator that lets you provision compute of your choice, storage of your choice, and networking. And it kind of prepack. It's like similar to you heard things like Kubernetes. It's an orchestrator to run these containers. Like the similar concept, but this is mainly for HPC, where you'll only provision these infrastructure at scale and storage at scale. And once the cluster is configured, it's running, and then you'll be able to run these batch workloads at scale. If you see this, because my work is done, now my VMs are being deleted, right? So that's where we provide cost savings to our customers. So just to keep the cluster active, I'm running this. So there is something like SQ. In case of FQ, it is telling me now the job is in the queue. It is provisioning the VMs on demand, and then the jobs will run. And then once the jobs are done, you should be able to see. And if you see this, I'm not doing really anything a real complex workload, but if you see, I'm just printing the host name actually, right? So yeah, so, but this could be any real workload for further analysis of the EDA, right? But that's what it does. Obviously, the Slurm has a dictionary of commands, the workloads and everything. But my goal is to demonstrate how Azure Cycle Cloud runs at scale for customers to run their EDA workloads, right? So the EDA workload can be run in the form of one of these schedulers. Some customers use Altair, some customers use Slurm, some customers are comfortable running these IBM workloads, because this is some sort of a, as I mentioned, a lift and shift, because you wanted to really simulate your on-prem environment, but take advantage of the cloud elasticity in terms of regions, in terms of the availability, scalability, durability, and all those things, right? So that's what this thing provides. And once you have these a cluster available, you should be able to continue to see these VMs being provisioned. And there are several things to optimize these things, like build your own custom image. That way you have your custom software installed. The VM boot up time will be much faster. Otherwise, we will be provisioning these Azure Compute VMs on demand, which takes some time. But that's outside the conversation of this, and that's outside the scope of this meeting. But the goal is to demonstrate how Azure Cycle Cloud can be used as a one-stop shop to provision infrastructure for monitoring, for reporting. As you could see, this continues to show you my activity and all those things, right? So that's what I wanted to show you. And going back to my slide deck, this is actually these are some of the vendors that we work with to run these EDA workloads. You name it, they are available in Azure Marketplace to run these deep learning workloads, or if you are an ISV who will be running developing a SaaS solution on Azure. Some of them are already available, like Altair or Dassault. They will provide some SaaS solutions. But on top of it, we have a defined compute, very beefy compute that's available, purpose built. When we say purpose built, these are essentially needed to run HPC workloads. They come with a price tag, but that's what you need to run these EDA workloads at much lesser time for design analysis, verification, and post analysis, and all those things, right? So, and then we highly encourage you to kind of check out microsoft.com/HPC. That will allow you to talk about some of our HPC solutions as well as this. So if you go to microsoft.com/HPC, it will really show you what kind of things that we do in different verticals like automotive or health sciences and silicon manufacturing. So what I talked today is about silicon, right? Silicon is where you run these EDA workloads, but HPC is more than that. right? You could use these high performance VMs to run in these for genomics analysis or automotive AI, whatnot. But today I focused on this just EDA analysis. And there's also a big write-up on what's InfiniBand is, in case if you are unaware. I would highly encourage you to check it out. It's available in some of these Linux VMs queues. Okay, so that's pretty much it. I just wanted to give you a high-level overview of it, but I highly encourage you guys to check it out from the Azure portal if necessary. If your organization needs these high-performance workloads in Azure. Thank you.
Thank you, Kumar.
If there are
Thank you.
any
Any
questions,
questions?
happy to answer.
I don't see any questions in the chat window. Thank you. That was very informative, man. Thank you very much, everyone, for joining, and hope to see everybody next week. And thank you, Kumar. Really appreciate it. Have a wonderful weekend and stay safe, folks. Bye-bye.
All right, thank you all. Bye now.
Yeah.